Hey guys, I'm here to go through the homework with you and try to help you out with that a little bit if I can. We're going to zoom in on this so you can see what I'm typing, and we'll go through that. And you got a test tomorrow, so make sure you study. The first question said, identify the parts of the neutralization reaction, the acid, the base, the salt, and the water. This is a pretty standard reaction between a base, right here. You can know it's a base because it's got hydroxide in it, and an acid. This is sulfuric acid, H2SO4, and in the reaction, the cation from the acid, the hydrogens, and the anion from the acid, the hydroxide, combine to make water. That's the H2O, obviously. And the anion from the acid, the sulfate, and the cation from the base combine to make a salt. And remember that a salt in acid-base chemistry is anything that has a positive and a negative ion together. So you need to be able to identify those four parts of a neutralization reaction. Remember that neutralization is called neutralization because an acid and a base mix together to make a salt and water. When it asks what type of reaction it is, of course that is a double replacement reaction because A plus B, or AB plus CD makes AD plus BC. We need to know the difference between completely dissociating and not dissociating acids and bases. When something completely dissociates, that's going to be a strong acid and a strong base. And we know that the opposite of strong is weak, so it is a weak acid and a weak base that do not completely dissociate in water. With litmus paper, I always tell you guys to remember using the letters and the colors. So if red litmus turns blue, and there's the key, it's turning blue. Some people get distracted by the red. If it changes into a blue color, it's going to be a base that you're testing. Blue goes with base, BB. If we look at this picture I found on YouTube, let's find that. That helps you remember a little bit. Look, red litmus paper with a drop of base, and blue litmus paper with a drop of acid changes to red. Blue litmus paper turns red, like I just said. It's an acid. Remember, acid, red, the D and the D will hopefully help you remember. If a solution has a pH of 4, how many more times acidic is it than a solution with a pH of 7? The trick here is to really remember that pH is a logarithmic scale. So we look at the difference between 7 and 4. 7 minus 4 equals 3. And we take 10 and we raise it to the third power. So 10 cubed. 10 cubed is equals 10 times 10 times 10. And a shorthand of writing that is a 1 with 3 zeros. So 10 times 10 times 10, 10 times 10 is 100, times 10 is 1,000. Notice that there are 3 zeros, and the difference between 7 and 4 is 3. That's an easy way to remember that. If you can do that, you can do number 8. For this one, you need to know the names of the acids and bases I asked to memorize. That's sodium hydroxide, hydrochloric acid, nitric acid, calcium hydroxide, you should know, potassium hydroxide, and sulfuric acid. When an acid and base react, this is answered in question 1, so I'm not going to go through that with you. You should know 5 properties of acids. I'm not going to tell you what the properties are, you'll have to look those up, but I guarantee you can find them online. So go to Google, type in properties of acids and bases, and boom, acids and bases. First page, acids and bases, and look at all this stuff you can find. When you have to fill out a table like this, you're not going to have to fill out a table on the test like this, but you do need to recognize the relationship between the hydrogen ion concentration and the pH. Now, to find the pH of something, we're going to have to take the negative log of the hydrogen ion concentration. I'm going to review this with you before we start. One way of doing this is finding the exponent, in this case it's -3, and realizing that the pH is going to be around that exponent. Now, of course, there's no such thing as a -3 pH, so the pH is going to be close to 3. If the pH is 7, you can say that the H plus concentration is going to be 1.0 times 10 to the -7th. Notice that relationship between the pH and the exponent on the hydrogen ion concentration. Of course, if the pH is close to 3 or anywhere below 7, it's an acid. If the pH is 7, it's neutral. If the pH is, and if we plug this into our calculator and took the negative log of it, we would find that that's 8.5 times 10 to the negative fourth. We would find the pH is about 4, and that's still an acid. And this one, the pH is going to be closer to 11, so we'd say that's a base. The equation to solve for molarity, you'll need to know that. It'll be up on the blackboard. On the blackboard tomorrow. Yay! If you have the molarity of a solution in which 0.26 moles are dissolved in 0.457 liters, well, we just use the equation. Molarity equals moles divided by liters. Remember, MOL, moles over liters. So we do 0.26, and we divide that by 0.457. Now you should know before you even do the math, when you have a smaller number on top and a bigger number on the bottom, the answer will be less than 1. So let's do this in my little calculator I've got here. How do you do that? There we go. We've got 0.26 divided by 0.457 equals 0.568. 0.568 m. We use capital italicized m for molarity. Let's stop there.